Hello, and welcome to the Snoozy Scientist, where we explore big questions in a calm and quiet way. Tonight, we're drifting into a quietly profound mystery. Is there an end to space? It might sound like a silly question at first, but the more you think about it, the more it makes your mind stretch, just like the universe itself. As always, I hope this video helps you relax. Maybe it helps you fall asleep, or maybe it simply lifts your mind a few billion light years away from the noise of the day. There's always the small risk that it might be too interesting and keep you up just a little longer. But if that happens, at least you'll have wandered through something beautiful. Before we float too far, I'd love it if you gave this video a like, and if you're new here, maybe even subscribed. It helps this tiny, sleepy channel stretch just a little farther through the stars. And if you're feeling cozy enough to share, tell me where you're listening from and what time it is for you right now. Are you winding down in a quiet bedroom in Lisbon at 10:42 p.m.? Or maybe sneaking in a moment of calm on a lunch break in Vancouver? It always brings me joy to see where our sleepy little community is tuning in from across the world. Now go ahead and settle in. You don't need to take notes. You don't need to remember a thing. Just let the words wash over you like soft waves of starlight. And as we begin this gentle voyage into the vast unknown, remember this video is for educational and relaxation purposes only. It's not meant as medical advice or a substitute for professional care. Ready? Let's begin. So, what is space? When we look up at the night sky, it seems like there's a lot of nothing out there. Stars twinkle, the moon glows, but in between, just empty blackness. At least, that's what it looks like. But here's the strange part. Space isn't really empty at all. In fact, space is one of the most active and mysterious things in the universe. It's not just a blank stage where the planets and stars perform. Space is part of the story. Let's go back in time for a moment. Before modern science, before telescopes, before physics, long ago people believed that space was just nothing, a big quiet void, a background that holds everything else. And that makes sense, right? After all, if you remove all the planets, all the stars, and all the dust, what's left? Well, space. But in the last 100 years, scientists have discovered that space isn't just the leftover part. It has structure, it has rules, it can stretch, bend, ripple, and even grow. Space isn't nothing, it's something. Imagine holding a soft blanket. You can stretch it, fold it, or shake it. That's a little like what space is. It's a kind of invisible fabric that fills the universe. You can't touch it or see it directly, but it's there, holding everything together. When something heavy like a star or planet sits on this invisible fabric, it bends the space around it. This bending is what we feel as gravity. We don't fall toward the earth because it pulls us like a magnet. We fall because the earth has curved the space under our feet. Even light follows these curves. A beam of light traveling near a galaxy will gently bend its path like a river flowing around a rock. That's how powerful space is. It tells even light which way to go. And that's just the beginning. Scientists used to think that if you took everything out of space, all the stars, all the air, even all the light, you'd be left with true emptiness. But even then, something strange remains. At the tiniest scales, smaller than atoms, space is buzzing with tiny flickers of energy. Particles appear and disappear, little sparks flash in and out of existence. They're called virtual particles, and even though we can't see them, we know they're there. We can measure their effects. This background energy is called the quantum vacuum, and no matter where you go in the universe, even in the quietest corners between galaxies, it's always humming quietly in the background. It's like listening to silence and realizing there's still a soft sound underneath. Not silence after all, a whisper, a hum, a gentle reminder that space is never really empty. Now imagine every single point in space, no matter how far away, is connected by this invisible fabric. That's what space does. It connects galaxies, stars, atoms, and even you and me. We're all floating in it. We're all made of it too, because everything in the universe, every piece of matter, every bit of energy exists inside space. But space also changes. It stretches over time. It can grow. That's what scientists discovered when they found out the universe is expanding. Galaxies aren't flying away through space like race cars. They're being pulled apart by space itself. The fabric is stretching. It's a little like dots drawn on a balloon. As the balloon inflates, the dots move farther apart, not because they're moving, but because the space between them is growing. This means space isn't just a place, it's a thing that moves, changes, and evolves. It has energy, it has rules, it has a history, and just like you, it has a future. So the next time you look up at the stars, try to see more than just blackness. Try to imagine the invisible fabric behind everything. Imagine it bending under the moon, stretching between galaxies, and humming gently all around you. Space isn't the empty part of the universe. It's the stage, the fabric, the whispering sea in which all things float. It may look like nothing, but it's everything. For a long time, space was just the background, a quiet, invisible stage where all the action happened. Then came a man named Isaac Newton. If you've heard of him, you probably think of the apple, a simple fruit falling from a tree. But that moment, real or not, sparked one of the most powerful ideas in science: gravity. And with it came a whole new way of thinking about space and time. To Newton, space was like a giant empty theater, big, silent, and still. It didn't move, it didn't bend, it didn't stretch or ripple. It just sat there, unchanging and endless, while the planets, stars, and moons moved around inside it, like actors on a well lit stage. And time? Time ticked forward, second by second, in perfect rhythm, like a drumbeat behind the scenes. Always the same, always steady. No matter where you were, time moved at the same speed for everyone. In Newton's universe, everything had a place, everything had a path, and everything followed the rules. If you dropped a ball, it fell, not because space told it to, but because gravity pulled it down. And gravity, according to Newton, was a force, a kind of invisible hand that reached across the void and tugged on everything with mass. The earth pulls on the moon, the sun pulls on the earth. Every star, every planet, every object in the sky is pulling on every other one all the time, like a cosmic web of invisible strings. And the amazing thing, Newton could describe all of this with math. He gave us laws of motion, simple rules that tell us how things move when they're pushed or pulled. He gave us a law of gravity, an equation so good it could predict where planets would be hundreds of years into the future. For centuries, this picture of the universe worked beautifully. It helped sailors navigate the oceans. It helped astronomers map the night sky. It even helped engineers launch rockets into space. Newton's universe was clean, logical, predictable, a place where everything followed the same set of rules. But it was also a bit rigid, because in Newton's world, space was just a container, like a big glass box. It didn't change, it didn't react, it didn't do anything. It just existed, holding everything else inside. And time. Time was like a master clock, ticking away in the background. Nothing could speed it up or slow it down. It just moved forward. The same for everyone, everywhere. This made the universe feel safe, understandable, like a giant machine ticking along exactly as it should. But as science kept growing, little cracks started to show. Things didn't always line up, especially when objects moved very, very fast or when they got very, very small. Some results didn't make sense in Newton's world, and questions started to bubble up. What is gravity really? How does it work through empty space? And what if space and time aren't just silent bystanders, but something more? It would take another genius, one with wild hair and a love for chalkboards, to answer those questions. But that comes later. For now, let's rest in Newton's universe a little longer. Picture it: a dark sky, scattered with stars, planets circling the sun in graceful orbits, the moon pulling gently on the oceans. Everything in motion, everything in order. No surprises, no chaos. Just a calm, quiet stage. Rules written into the fabric of the cosmos. And above it all, the soft ticking of time, steady and sure. If the universe were a play, Newton gave us the script, a way to read the motions of the heavens like lines in a story. And for a very long time, that story made perfect sense. Even now, when you toss a ball, swing on a swing, or watch the moon rise, you're living inside Newton's world. His rules still guide our everyday lives. His math still works. His picture of space still feels familiar, even if we now know it isn't quite the whole story. So as you drift off tonight, imagine yourself standing on that old cosmic stage, the stars above you, the earth beneath your feet, and all of it following invisible laws, quiet and exact, space holding it all, time moving it forward. And somewhere in the distance, the faint echo of an apple falling softly to the ground. Just when we thought we had space all figured out, a man with wild hair and quiet eyes came along and changed everything. Albert Einstein. In the early 1900s, Einstein looked at Newton's neat and tidy universe, the one with the perfect stage and the steady clock, and gently shook his head. He saw something different. Th- To Einstein, space wasn't a silent, empty box. Time wasn't just a drumbeat ticking in the background. Instead, he said, space and time were the same thing, woven together into one fabric called spacetime. Spacetime. Oh, it sounds like science fiction, but it's very real. And once you see the universe this way, everything changes. Imagine a giant sheet stretched tight in the dark. That sheet is space-time. It holds everything: planets, stars, galaxies, light, even you. Now picture placing something heavy like a bowling ball onto that sheet. What happens? The sheet dips. It curves under the weight. That's what mass does to space-time. It bends it. And gravity. That gravity isn't a mysterious pulling force anymore. It's not a hand reaching through space to tug on things. Gravity is just the shape of space-time, pure. When you drop a pencil, it falls because Earth has curved space-time around it. The pencil isn't being pulled, it's rolling down a dip like a marble on a hill. Even light follows these curves. It doesn't travel in straight lines. Not really. When light passes near a star or a planet, its path bends slightly. Not because the star is grabbing it, but because the space around the star is curved. This idea was radical. It was bold. And it was beautiful. In 1919, scientists tested Einstein's theory during a solar eclipse. They looked at the stars near the darkened sun and saw that their light had bent just as Einstein had predicted. In that moment, the universe changed. We no longer lived in Newton's tidy stage. We were floating on a soft, flexible fabric, a fabric that could bend, stretch, and even ripple. Yes, ripple. In fact, when massive objects like black holes crash into each other, they send out tiny waves in spacetime. These are called gravitational waves, and they move through the universe like ripples on a pond. We didn't detect them until 2015, but Einstein had predicted them 100 years earlier. That's how far his vision reached. Now, if all of this feels hard to picture, don't worry, you're not alone. Space-time isn't something we can touch or see. It's invisible, silent, and strange, but we feel it every day. When you walk, you're following curves in space-time. When the Earth moves around the sun, it's not being pulled, it's gliding along a bend in the fabric. When light from distant stars bends around galaxies, it's tracing those same curves. Einstein's universe is less like a machine and more like a soft dance. Everything moving, everything flowing, everything shaping, everything else. And here's the most mind bending part of all: time in Einstein's world isn't steady. The faster you move, the slower time goes. The stronger the gravity, the slower the clock. That means time moves differently in different places. If you live on a mountain, your clock ticks a tiny bit faster than someone living by the sea. You- if you were floating near a black hole, time would crawl almost to a stop. It's not science fiction, it's been measured. It's real. It's the universe we live in. Einstein showed us that space and time aren't just backgrounds. They're not passive. They respond to mass and energy. They have shape. They have feeling. We don't move through space and time. We move with them. So as you drift off tonight, imagine yourself lying on that great cosmic fabric. Feel the gentle dip of the earth beneath you. Feel the bend of space under the stars. And know that you're part of it all. Floating tonight, curving, sheer head, drifting through a universe that's soft, strange, and endlessly beautiful. A universe where space and time are not two things, but one, and it's holding you even now. Sometimes big ideas are easier to understand with small images. So tonight, let's use one of the most helpful ones, the trampoline. You may have heard it before. Scientists and teachers love this one. And once you picture it, the universe starts to feel just a little more familiar. Imagine a large, soft trampoline, one of the big ones, round and stretched tight across a frame. It's smooth and flat, at least for now. This trampoline is our stand in for space. Now, take a heavy bowling ball and gently place it right in the center. What happens? The surface sinks, the fabric stretches, it forms a dip around the weight. That's exactly what happens in space-time when something with mass, like a planet or a star, sits in it. The weight of the object bends the space around it, just like the trampoline. Now, take a small marble, set it on the edge of the trampoline, and give it a tiny push. What does it do? It rolls, and instead of moving in a straight line, it starts to spiral around the dip made by the bowling ball. This is how orbiting works. The Earth moves around the Sun not because the Sun is yanking on it with a string, but because the Sun is heavy. It's made a deep curve in space-time, and the Earth is just following that curve. The Moon orbits Earth the same way. Satellites orbit the Moon. Everything is gliding along the dips and slopes made by heavier things. It's not pulling, it's bending. And that's the magic of this trampoline idea. It helps us see gravity not as a force, but as the shape of space itself. Of course, the real universe isn't two dimensional like a trampoline. It bends in all directions. It curves up, down, sideways, and even in ways we can't fully picture. But still, the image holds. Heavy things curve spacetime. Light things follow those curves. And it's like they're dancing, each one responding to the shape the other makes. Now imagine something even stranger. Imagine two bowling balls placed far apart on the trampoline. Each makes its own dip. And now imagine rolling a marble between them. The marble's path curves and twists. It doesn't know which way to go. It's being influenced by both dips. This is what happens when you have two stars, or two galaxies, or two planets near each other. The space between them becomes a kind of tug of war, a gentle blending of curves, shaping the way everything moves. Even light doesn't escape this game. If a beam of light passes near a heavy object, like a star or black hole, it bends. It follows the curve like a marble would follow the slope of the trampoline. Einstein predicted this, and in 1919, during a solar eclipse, scientists saw it happen. The light from distant stars curved as it passed near the sun, not because the sun pulled it, but because the sun had bent the space around it. That moment was like watching a marble roll across a giant cosmic trampoline. And suddenly, the whole universe made sense in a new way. Even today, we use this idea. We rely on curved spacetime to send satellites into orbit, to aim telescopes at faraway stars, and to understand how black holes pull matter in. It's not just a neat image, it's real. And yet, it's still so gentle. It reminds us that the universe isn't made of sharp lines and cold math. It's made of curves, soft movements, slow spirals. So next time you bounce on a trampoline, or even lie on a soft bed that sinks beneath your weight, think about space. Think about the invisible fabric under your feet. And think about how your body, small though it is curving that fabric ever so slightly. And think about the stars above you, each one bending space with its weight, shaping the paths of light and matter like ripples on a pond. The trampoline might be a toy, but it's also a window into something much bigger. A picture of a universe that bends and sways and responds. A soft, quiet stage where gravity isn't a force. It's a shape, and you're floating in it. Right now, let's go somewhere quiet now. Really quiet. Imagine the emptiest place you can think of. A place with no stars, no planets, pure Fanus Wed, no people, no light, no sound, just space, rock, a perfect vacuum, or so it seems. Because even here, in the silence between galaxies, where it feels like nothing could ever happen, there's something going on. Tiny somethings. They blinking in and out of existence. And the vacuum of space is not truly empty. We'll uncover with Beethoven, and we'll uncover with Beethoven turned Friven. It only looks that way from far away. But if you could shrink down smaller than atoms, smaller than electrons, and peek at the fabric of the universe itself, you'd see something wild. Little flickers, tiny flashes, particles appearing and then vanishing. Here, pop, gone. These are called quantum fluctuations. They happen all the time, everywhere, even in the darkest parts of space. You can think of them like tiny jitters in the universe, little sparks of energy that show up, stay for just a moment, and then disappear again. Nobody invites them. They just happen. This might sound impossible, but in the world of quantum physics, even nothing isn't really nothing. It turns out that the vacuum, the most empty thing we can imagine, is actually buzzing with invisible activity. Particles and antiparticles appear in pairs, and they borrow a little energy from the universe, exist for a split second, and then vanish before anyone notices. It's like the universe is gently breathing. Inhale, a flicker, exhale, gone. And while these events are tiny, far too small for us to see directly, they are real. We've measured their effects in labs. They're part of why atoms behave the way they do. They even help explain why stars shine, why the sky isn't completely dark, and how galaxies came to be. In fact, these tiny flickers may have helped shape the entire universe. In Offlet ter Eshib. Some scientists believe that the quantum jitters in the early universe, right after the Big Bang, got stretched out as space expanded, and those stretched out ripples became the seeds of galaxies, all from the tiniest wiggles of nothingness. It's strange, isn't it? We used to think of space as still, calm, empty, but now we know it's more like a restless sea. Not wild or loud, but quietly alive, always moving even when it seems still, always whispering even when we hear silence. The more we zoom in, the more we realize that stillness is just an illusion. Even in deep space, where it seems like nothing could ever stir, the universe is humming. It's like a song we can't quite hear. Too soft, too fast, too small, but it's there. And here's a fun thought. Those little blips in the vacuum, they appear everywhere, not just in space, but around you, right now, even in the room you're in, with between your fingers, and inside your pillow, in the space between atoms. The quantum world never rests, and, and yet it doesn't feel busy. Well, it doesn't feel loud. It's a kind of peaceful movement, a hidden rhythm beneath the surface, like ripples on a lake at night, barely there, but gently changing everything. So as you lie back and drift off, imagine the space around you, not as empty, but as gently buzzing, alive with tiny flickers too small to see. The pillow under your head, the space behind your eyes, even the distance between the stars. Nothing is ever truly still. Even in the silence, the universe dances, and you, dear dreamer, are part of that dance, floating in a sea of invisible sparks, and surrounded by a quiet that's never quite quiet, a vacuum that's never quite empty, and a universe that never ever stops moving. Let's start with something gentle. Close your eyes and picture the universe. And what do you see? Maybe stars? Planets? Particles? Tiny dots moving through space? But here's something quietly surprising. In modern physics, things aren't really things at all. They're fields. Soft, invisible, ever present fields. And suddenly, the universe becomes something very different. It's not a collection of objects, it's a collection of ripples, waves, vibrations, and something deeper. Imagine a calm, endless ocean, and you can't see the water moving, not yet, but throw a stone and ripples appear. That's how physicists now see the universe. Everything is made of fields, and what we call particles, they're just little ripples in those fields. That Will's lot for Milik, Will's mind is scorpion. The electron, a tiny ripple in the electron field. The photon, light itself, A ripple in the electromagnetic field. Quarks, the tiny pieces inside protons and neutrons, ripples in their own special fields. Each kind of particle we know comes from its own field, stretched across the universe like an invisible blanket. And here's the wild part: those fields are everywhere, always, even in the vacuum of space. E- Even in the quietest corner of the universe, those fields are still there, still buzzing, still gently alive. In fact, space itself is made of fields. When we say the universe is empty, what we really mean is it's full of fields that aren't currently rippling, but they're there, patient, present, wait, tachyperforming, and waiting hyper, and way. Now let's go a little deeper, gently, of course. Let's say you're sitting in the middle of space, nothing around, nothing in sight. It feels like there's nothing there, but you're sitting inside a sea of invisible fields. And the moment a ripple appears, just the tiniest wave, suddenly something is there: a particle, a photon, a speck of matter or energy. Not because something flew in from far away, but because a field was disturbed. And that disturbance is the particle. It's like plucking a string on a guitar. The string was always there, but the sound only came when you touched it. That's what the universe is like. If fields are the strings, particles are the music, and the space between stars, the nothing, is more like an instrument waiting to be played. This idea is called quantum field theory. It's the best picture we have of how everything works. Not with little marbles flying around, but with ripples and fields, gentle waves moving through invisible oceans. It's beautiful, isn't it? Everything we see, all matter, all energy, is just a ripple. Even you. Yeth, Walbelsi, even your thoughts. Your body is made of ripples in the electron field, the quark field, the neutrino field, and more, all dancing in harmony, all held together by invisible rules. And somehow, from all those tiny waves, you exist. You're not a solid thing. You're a shimmering pattern in a sea of fields, just like the stars, could just like the galaxies, just like light. Well, it's easy to forget in the rush of daily life. We think we're sitting still, solid, stable, but underneath it all, we're made of motion, of gentle vibrations, of tiny songs playing in a silent sea. So, as you lie back tonight, try to imagine it: the world around you quietly humming, not with sound, but with invisible waves. Fields stacked on fields, layered like soft blankets across the universe. And inside those fields, little dances of energy, flickers of light, with tiny echoes of creation. It makes you wonder, what is space, really? If it's full of all these fields, it's not a stage, not a backdrop, not a box. Space is the fields, alive, the buzzing, the art singing soft lullabies that stretch from here to the stars. And you, dear dreamer, are part of the melody. For a ripple among ripples, floating, the flickering, forever connected to everything. If you sit in a quiet room long enough, you might begin to notice something: a soft sound, a hum, not from a machine or the wind, but from everything around you, just barely there. Now imagine doing that in space. No air, no sound waves, no noise at all. Total silence, right? Not quite. Will I beside Valwada, Peacock Naughting, Because even in the vacuum of space, something hums. You can't hear it with your ears. But the universe has a background whisper, a soft vibration that never stops. This is called vacuum energy. It's the energy that lives in space itself, not inside stars or galaxies, not trapped in atoms or light, just there, quietly existing in the emptiness. Even when nothing else is around, the vacuum has energy. Not a loud shout, well, a whisper. Scientists once thought that empty space was truly empty. No particles, no fields, no motion. But then came a surprise. They discovered that even when they removed all the matter, all the heat, all the light, something still remained. Something restless, little fluctuations, tiny bits of energy, always there, always moving, like ripples on a pond that no pebble ever touched. This energy isn't something you can see. It doesn't glow or burn or flash, but it's there, and it shapes the universe. You might remember those quantum jitters we talked about earlier, particles popping in and out of existence. Vacuum energy is their home. It's the backdrop to the entire play. If particles are the actors and spacetime is the stage, then vacuum energy is the faint music playing in the background, setting the tone, filling the silence. But here's where it gets really strange. This gentle hum of energy might actually be pushing the universe apart. Scientists think vacuum energy could be the reason space is expanding faster and faster. You might have heard of dark energy, that mysterious force that seems to be stretching the universe wide open. Many believe dark energy and vacuum energy are one and the same. That quiet hum isn't just background noise, it's power, subtle, patient power, stretching the fabric of space like a balloon being slowly blown up from the inside, not because of anything in space, and but because of space itself. It's a strange thought that the emptiest parts of the universe are filled with invisible motion. That silence has a song, that stillness has strength, and we're only just beginning to understand it. Physicists have tried to measure the vacuum energy in numbers, to calculate it, to put it in neat equations, and but when they do, the math explodes. The numbers are wild, much too big to match what we see in the real universe. Some call it the worst prediction in the history of physics. Others say it's the universe reminding us that it still holds secrets, that the quietest parts are often the most mysterious. So tonight, as you drift deeper into sleep, imagine the space around you humming softly, not with sound, but with motion, with presence. The bed you're lying on floats in this sea of silent energy. The earth spins through it. The stars burn within it. And all the while, the background hum continues. Not loud, not angry, just there, like the echo of a lullaby from the beginning of time. You don't need to understand every detail. You don't need to remember the terms. Just know this: space is never truly empty, and silence is never truly silent. There is always a hum, always a whisper, always a gentle reminder that the universe is alive, and knowing even in its quietest places. Let's imagine something simple. You walk outside on a clear night. You look up, and there they are, stars. Some are bright, to Ding Kosai, to the Bienemi Some are faint, but all of them are part of something you can see, something your eyes or a telescope can catch. That something has a name. We call it the observable universe. It's a soft sounding term, okay, but what it means is powerful. But it means everything we've been able to detect, and every star, planet, galaxy, or flicker of light that has ever reached us since the beginning of time, not the whole universe. If you are just the part we can see, imagine standing in the middle of a quiet field, turning slowly in a circle. Now imagine doing that with light, looking out in every direction. Light coming at you from every side, from the farthest corners of space. That's what the observable universe is. It means a glowing sphere of light, stretching out about 46 billion light years in every direction. That's 93 billion light years across in total. Yes, you heard that right. Even though the universe is only about 13.8 billion years old, the edge of what we can see is much farther. How can that be? Because while the light was traveling toward us, the space itself was expanding, stretching, growing again. So something that was 13.8 billion light years away when it sent its light is now much farther. It's like blowing up a balloon with tiny dots on it. As the balloon grows, the dots move apart, not because they're moving, but because the space between them is. And here we are, sitting on one little dot, and catching light that left galaxies billions of years ago, light that has traveled across time, across the expanding sea of space, all the way to us. The observable universe is a time machine. Everything we see, far away, is also old. Look at a nearby star. Maybe you're seeing it as it was 10 years ago. Look at a distant galaxy. That light left 10 billion years ago. It's like opening a photo album of the cosmos. But the farther you go, the older the pictures get. And past a certain point, there are no more pictures. Not because there's nothing there, but because the light hasn't reached us yet. The light is still on its way, still traveling, still trying to get here. But the universe is so big and growing so fast that some of that light never will. Beyond the edge of what we can see, space continues. Galaxies float in silence. Stars burn, live, and die. But to us, they're invisible because the light hasn't made it here and maybe never will. So we call that edge gently, simply the boundary of the observable universe. Not a wall and not an end, just the limit of what light has had time to show us. If the universe is a great cosmic stage, then the observable universe is just the part lit by our spotlight. Everything else is still hidden behind the curtain, and that's okay. It means there's more to wonder about, more to explore, more to dream of. Somewhere out there, far beyond our view, could be other galaxies, other stars, other places we'll never see. But the part we can see, it's already breathtaking. 2 trillion galaxies, two, each with billions of stars, clouds of gas, pure rivers of dust, because light echoing from the Big Bang itself. All of it wrapped around us like a glowing sphere, quiet, massive, ancient. So tonight, as you drift off to sleep, imagine yourself floating at the center of that sphere. Not because you're special, but because wherever you are in the universe, that's your center of view. Everyone has their own observable universe, a little bubble of light, a soft shell of history, a glowing echo of all that's come before. And in the middle of yours, quietly breathing, gently thinking is you, watching, would you, listening, dreaming, Here's a quiet question that often floats to the surface once we learn about the observable universe. Why is it so big? If the universe is only about 13.8 billion years old and nothing can move faster than the speed of light, how can the observable universe stretch out over 93 billion light years across? It seems too big, too wide, like something doesn't add up. But the answer is gentle and cosmic and, and a little bit magical. It has to do with a quiet secret. Space itself can expand, and where do all luda spates when they kramer everus for minma the pabrard coming cover ein and comes by decken eri kunnu, while falafaris u for mened course of the bull of the sandry. Not just things moving through space, but the space between things, growing, stretching, well, widening like a rubber band. Imagine light traveling across space like a tiny runner on a road. Now imagine that road stretching while the runner is still moving. Step by step, the road grows longer under their feet. Even though they're running as fast as they can, the finish line keeps drifting farther away. That's what happened with the light we see. When a galaxy sent out its light long ago, maybe 13 billion years ago, space was smaller, tighter, more compact. But as that light traveled toward us, the space it crossed kept stretching, bit by bit, moment by moment. The light was doing its best, moving at its constant speed, but the universe was growing underneath it. And because of that, the distance the light had to cover got longer. That's why the edge of the observable universe isn't 13.8 billion light years away. It's much farther because the space between then and now has expanded, stretched gently like a bedsheet pulled at the corners. Not all at once, but slowly, patiently, pure sight of the cane Nishabrecht, and those pret hewer sight, and Kendride Cleacher scorpions, like a breath that never quite ends. The result? What began as a 13.8 billion year journey turned into a much longer one. And now, that ancient light comes to us from galaxies that are 46 billion light years away. Each photon, each tiny particle of light, is like a traveler, a cosmic message in a bottle, sent across a sea that was calm at first, then slowly began to swell. And yet, it made it here, to us, to this moment, to your screen, to your ears. But light that started its journey before Earth had formed, whispering stories about a universe long ago. But the space that light crossed didn't sit still. It stretched. That's why the universe feels so big. Because it is, but not because things flew away from each other fast, but because the in between grew wider. In the early moments after the Big Bang, that growth happened at an incredible pace. We call that time cosmic inflation, when space itself ballooned in an instant, faster than light. Not because anything broke the rules, but because those rules allow space itself to grow. Remember, nothing in space can travel faster than light. But space itself isn't a thing with speed limits. It can stretch as fast as it wants, like a magic carpet unrolling before your eyes. So when we ask why is the universe so big, we're really asking how did space grow so much in so little time? And the answer is because that's what space does. It grows, it breathes, it makes room, and in that room, light moves forward, always moving, never stopping. First, but never alone, but never alone, but carried by the fabric of space. lifted by the quiet motion of the cosmos. So tonight, as you rest your head, think of those tiny photons, those little packets of light gliding across an ocean that keeps changing shape beneath them. They've been traveling for billions of years through a universe that refuses to sit still. And still, they found you. Their journey was long. The road kept stretching, but the light kept going. And now, after all that time, it gently lands here to help you fall asleep, to remind you that the universe is wide, yes, yes, but also kind and full of light. Even when the road is long, even when space grows larger than we can imagine, some things still reach us, and even across the vastest distances. And let's imagine you're standing in a wide open field. You look around, be as far as your eyes can see, that's your world. But what about beyond the hills? And why beyond the trees in the distance? You can't see what's there, not because it doesn't exist, but because your eyes haven't reached that far. That idea, that gentle limit, exists in the universe too. We call it a cosmic horizon. It's not a wall, not a fence, not the edge of the universe. It's just the farthest point we can see, a soft boundary, a fading line in the distance. Because light, as fast as it is, needs time to travel. And the universe is young, at least in cosmic terms, and just 13.8 billion years old. So light from very far away hasn't had enough time to reach us yet. It's still on its way, still crossing the expanding sea of space, still gliding forward one photon at a time. Imagine a lighthouse blinking in the far distance, its beam shining toward you. But the light hasn't arrived yet. With you know it's out there. You believe it's coming, but for now, the darkness between you remains. And that's what lies beyond our cosmic horizon. To galaxies may be there, stars and planets, even entire clusters of galaxies. But we can't see them, not because they're hidden behind something, but because their light hasn't made the journey yet, and maybe never will. Because the universe is expanding, and in some distant places, it's expanding faster than light can catch up. So even though the light is trying, the space between keeps growing. They love, and the signal gets left behind. That's the strange thing about cosmic horizons. They aren't fixed, and they change with time. Every second that passes, light travels a little farther, and we see a little more. Our horizon stretches gently outward. But some parts of the universe will always stay beyond it, forever invisible, forever out of reach. Not because we're not trying, but because the light can't win the race. It's like standing on a beach, watching the waves roll in. You can see the ocean stretch into the sky, but you'll never see what's beyond the curve of the earth. And that's okay, because the universe still gives us so much to see, so much to explore. Wow, so much to imagine. Cosmic horizons remind us that we live in a story still being written. That light is always arriving, always telling us something new. A galaxy that was invisible yesterday might become visible tomorrow because its light finally crossed the distance, finally touched our eyes, finally whispered its story. And when we look far, we also look back. Farther means older. So these horizons aren't just limits of space, they're also limits of time. The edge of what we can see is also the edge of what we can know. Beyond that, the universe continues, It doesn't stop. It doesn't fall off. It just becomes a mystery, a soft blur beyond our sight. Some scientists wonder, could there be other cosmic islands beyond our view? Other regions of the universe, separated by distance and time? Maybe, for maybe not. And we may never know. But that's part of the wonder. Not knowing isn't scary, it's peaceful, like looking out at the stars and smiling at how little we understand. So tonight, as your eyes grow heavy, picture yourself sailing through space. Ahead of you, a soft horizon glows, not with fire, but with possibility. Beyond it, the unknown stretches on forever, quiet, patient, and waiting. You don't need to reach it. You don't need to see it all. Just knowing it's there and it's very is enough. Because in a universe this big, every edge is just the beginning of something more. And your journey through the stars, it's only just begun. When you look up at the night sky, when you look, you might think you're seeing things as they are right now. Stars twinkling, weak galaxies shining, the darkest the pair, the universe alive above you. But you're not seeing the present, you're seeing the past, because light takes time to travel. To, and the farther something is, the older the light that reaches your eyes. This is what scientists call look back time. It's a gentle, haunting idea. The deeper we peer into space, the further back in time we're looking. That star glowing faintly above your window, its light may have left before you were born, maybe before your grandparents were born. The light from some galaxies, it started traveling billions of years ago, before Earth had trees, before dinosaurs, before oceans had fish. We're not looking at what is, we're looking at what was. The sky is filled with ghosts, not in a spooky way, but in a beautiful way. And each glimmer, each twinkle, each shimmer of distant starlight, fermenting, planketing, circling with eating swims, is a message from long ago, a kind of cosmic postcard, stamped across time. Hello from the past, it says. It says, here's what I looked like 10 billion years ago. And we read it, and quietly, curiously, with telescopes and wonder. Imagine holding a mirror to the universe, but the reflection comes back late, very late, well, like watching home videos from a time before memory. That's what stargazing is. And galaxies that look small and faint now may actually be huge and bright today, but we won't see that for billions of years. And because we're always catching up, always receiving yesterday's light. And if a star exploded just now, a million light years away, we won't know for another million years. And that's the delay baked into the cosmos. Time and space are stitched together, and light moves across that fabric at one steady pace. So space is like a time machine. Each step outward is a step backward. Look up, and you're gazing into the history of everything. A fossil record made of photons, and Skirjerd, a sky filled with ancient stories. This is why astronomers talk about baby galaxies at the edge of the observable universe. They don't mean the galaxies are babies now. They mean we're seeing them as babies because their light has taken that long to arrive. We see their first steps, their first bursts of stars, their early collisions and shapes, and just beyond that, we see the afterglow of the Big Bang itself, the faintest, oldest light, The cosmic microwave background, a whisper from when the universe was only 380,000 years old, long before stars, long before anything had form, just a warm bath of light, stretching in every direction. It's still here. It's still glowing, still telling the first chapter of our cosmic story. So the next time you look up at the stars, right, try this. Don't just see dots, see messages, see memories. That bottle, too. See time itself, frozen in flight. From it, the sky is not just above you, it's behind you, stretching through layers of light and history. It's a soft reminder that we're always living in the middle of a great unfolding, and that space, being, is also time. So tonight, as your eyes close and your thoughts grow quiet, imagine drifting backward, not just through space, but through the ages, sailing past newborn stars, young galaxies, prepare over the vault of the and flickers of ancient light. The universe doesn't just tell you where, it tells you when. And in this slow motion slideshow, every glimmer is a gift from a time long gone. You're not just looking outward, you're looking back. And that is a kind of magic all its own. Picture this: you're standing by a calm lake at sunset. The sky is painted in soft reds and oranges. You toss a pebble into the water, and the ripples spread out in perfect circles. Now imagine those ripples stretching, growing wider and farther apart. Not because you threw the pebble harder, but because the surface of the lake itself is expanding. That's a little like what's happening in space. But instead of ripples, we're watching light. And instead of water, we're watching space-time itself grow. You see, space isn't still. It's stretching, slowly, quietly, constantly. And when light moves through that stretching space, and something strange and gentle happens. The light begins to stretch too. We call that stretch redshift. It's not because the light turns red on purpose. It's just that as the wave of light is pulled longer, its color shifts. Light comes in a rainbow of colors. Each color has a wavelength, a kind of rhythm like music. Blue light has short, tight waves. Red light has long, stretched out waves. So when light is stretched, its waves move from blue to green to orange to red, and sometimes beyond red into invisible light called infrared. It's like taffy being pulled slowly apart. The longer the stretch, the redder the light. And the more stretched it is, the farther it's traveled. The older it is, the faster the space between has grown. So when scientists look at galaxies far away, they study their light, and notice how red it has become. That red tells a story of motion, a story of distance, a story of expansion. The greater the redshift, the faster that galaxy is moving away from us. And not because it's flying through space, but because the space itself between us and the galaxy is growing. You're not watching a spaceship speed away. You're heck not watching any way. You're heck not watching the back. You're watching the road beneath it get longer. This is how we know the universe is expanding. Not from sound, not from movement, but from color. From light that arrives to us stretched, softened, reddened by the growing fabric of everything. It's gentle proof that the cosmos is breathing, stretching, in the becoming more. Even now, right as you listen, light from distant galaxies is being pulled ever so slightly longer. It doesn't make a sound. It doesn't shake the stars, but it leaves a clue. And in color, think of redshift as a cosmic whisper, a soft note in a never ending song. We use it to measure the speed of expansion, to map out the distance of galaxies, to look back into time. Some galaxies are redshifted just a little. They're nearby. Their light hasn't stretched much. Your others, they're so far away their light is stretched by factors of 10, 100, even more. They've been on a long journey, and they've carried their stories all this way. And here's the amazing part. Do that stretch of light, be- that slow shift into red, helped scientists discover something even bigger. That not only is the universe expanding, it's expanding faster and faster. We call that mysterious acceleration, dark energy. We'll whisper about that later. For now, let this settle in gently. When you look at the night skies, you're not just seeing light, you're seeing movement. You're seeing the universe pulling itself apart. Not violently, but like dough rising, smooth, slow, relentless. The stars aren't running from us. They're carried by the stretch of the fabric beneath them, and that stretch, it leaves a trace in the light. So tonight, as your eyes close and your thoughts begin to drift, imagine floating on a sea of space that's always expanding. The stars around you stretch away, not with noise or fire, but with the color of their light shifting softly into red. A signal, a lullaby, a cosmic reminder that change can be quiet and still leave an echo. Imagine you're standing at a train station. A train pulls away slowly, slowly, but then faster still. At first, you can see its windows, its lights, but its little flicker disappearing into the distance. And- But then, it goes so fast, you know you'll never see it again. No matter how long you wait, no matter how hard you squint into the horizon, that's what's happening that with some galaxies in our universe right now. They're not just far away, they're moving away so fast that the light they're sending out today will never reach us. Not in a million years, ever, not in a billion, not ever. They've crossed a kind of invisible line, a distance so great and a speed so fast that they're drifting into a part of the cosmos and what it will never catch up to. It sounds dramatic, but it's not sudden. It's slow. It's slow, quiet. And way one squired oped quack, discover bursts per social veritiv, like watching a ship sink below the curve of the earth. They don't disappear with a flash. They fade, bit by bit, be redder and dimmer each year, until their light is too soft to see. And one day, firm up, they won't be part of our sky at all. They will still exist, still full of stars and stories, but not for us. Because space isn't just stretching. In some places, it's stretching faster than the speed of light. Wait, how can that be? Didn't we say nothing moves faster than light? That's true for objects through space. But the fabric of space itself can stretch faster than light without breaking any rules. It's like drawing dots on a balloon and blowing it up, and the dots stay still, but they grow farther apart because the surface between them is expanding. That's what's happening to those faraway galaxies. They're not flying away on rockets, they're being carried by the space that lies between us. And that space? Feared sp- it's growing too fast for their light to ever make it back to us. Even though they're still shining, their new light will never arrive. Only the old light, and recounting tonight, just what you faded for a hungered hast berzak to fate wars. The patayukan spethia spikebald from Blag Wat, the Humzan Rang, will I warden spethia spike tonight, for minute prestia cosper, the pute the alvern plily, with the old light, the light sent long ago, can reach us. And once that final wave of light washes over us, they'll be gone from our view, like distant campfires snuffed out by the wind, but not because they stopped burning, only because their warmth can't reach us anymore. You're, this is one of the saddest, strangest truths in all of cosmology. Our universe has an event horizon and a boundary, not like a wall, or, but like a soft edge of knowing. Will beyond it, the universe continues, but it becomes unreachable, unseeable, forever out of touch. Even if we built the fastest spaceship imaginable, we couldn't reach those galaxies because the space between us and them would grow faster than we could fly. It's a gentle kind of goodbye, a cosmic wave from afar. It also means this: every year that passes, more galaxies slip beyond our horizon. The universe is growing, not just larger, but emptier, bored from our point of view. You know, billions of galaxies will vanish from our sky over the next trillions of years. And if some future astronomer were to look up from Earth long after we're gone, they might not see much at all, just a few lonely stars, maybe a single galaxy, Wurelevi. They might think the universe is small and still. They might never know how big it once looked. Is he how rich and crowded the sky used to be? Unless they discover our records, our telescopes, our maps of redshift and reach. Then they'll know there was more, so much more, and they'll remember us, not just as stargazers, but as timekeepers of the fading sky. So tonight, as you rest, picture those distant galaxies, still spinning, still glowing, still full of stories we'll never hear. But for a moment, they touched our eyes. They sent their light across a billion-year sea, so we could see them just once. And now, they sail on beyond forever. But that's not sad. It's beautiful. Because even if their new light won't reach us, we were lucky enough to see them at all. In the vast hush of space, a glimpse is a gift. In a single spark in the darkness, we'll uncover how hunger's spark is enough to light a lifetime of wonder. Close your eyes for a moment and picture space. What do you see? Maybe a dark, starry void. Maybe galaxies drifting like glowing boats. And maybe, somewhere far away, a wall, a place where it all ends. It, that idea feels natural, comfortable, like space should be a big cosmic room. And somewhere at the edge of that room, there must be a wall, or a fence, or at least a sign that says, "You've reached the end." We imagine the universe like we imagine houses, or fields, or oceans, things that start and stop, but that have shapes and boundaries. Will that exist inside something else. But here's the thing: the universe doesn't follow the same rules as our kitchens or parking lots. It doesn't have edges the way a table has corners, or a playground has fences. Still, we expect them, We want them. We want them because we're human, and human minds love edges. From the time we're children, we ask questions like, what's on the other side? What happens if I go all the way there? Where does it stop? Needed. We like maps with borders, in stories with endings, pictures with frames. It helps us feel safe, like we know where we are and what's possible and where it's okay to stop wondering. But the universe doesn't care about our fences. It may not have a border at all, not even a soft one. Gone. Not even a place where things thin out and say, that's far enough. Imagine the surface of the earth. You can walk in any direction, and you'll never fall off. You might circle back eventually, but you'll never hit a wall. Now imagine something like that, but in 3 dimensions. If that might be what space is like. It doesn't need to have a brick wall at the end. It can be infinite, or it can be finite and unbounded, curved back on itself in ways we can't see from inside. No fence, no door, no edge, just more. More galaxies, more emptiness, more time. And still, we wonder, where's the limit? What lies beyond? But sometimes, that question, where's the edge, only makes sense because our minds are built for rooms. Our brains evolved to spot cliffs, to find shelter, and to know where the path ends so we don't walk off it. So, of course, we expect the universe to do the same. But space doesn't have to stop. It doesn't have to be inside anything. It can simply be. That can feel uncomfortable, like a dream that never settles. But it's also freeing. There's no need to find the outer wall. There's no need to ask what's on the other side of the end. Because maybe, just maybe, there is no end. Just like there's no end to numbers, no final breath of music, no last question to ask. The universe may be an open book, but not a book with covers. It may go on forever, it, or it may loop in ways we can't detect. Either way, it doesn't stop just because we want it to, and that's okay. And that
Tonight.
as your thoughts slow down and float, notice how your mind looks for edges. You might catch yourself thinking, where does this go? When does it stop? And that's perfectly normal. It's part of being human. But you're floating now, and in the quiet sea of stars, there are no walls to bump into, no need to reach the end. Let your thoughts stretch like space itself, wide, soft, no, without edges. Because sometimes the best way to rest is to let go of the map and drift in a place where borders don't matter. You are not boxed in. You are not enclosed. You are part of something vast, something open, something that doesn't have to stop. And in that endless sky, you are free. Let's play a quiet little game. You're holding a piece of paper. It's smooth, flat, and stretches far in every direction. If you could walk across it forever, you'd never fall off and, and never loop back. And that's one kind of universe will Zeph Perbican Homeville. Now, picture a balloon. Its surface is curved round like a bubble. If you walk along that balloon, you'll eventually end up back where you started. You'd never hit a wall, but you'd still be in the same space. That's another kind. And finally, imagine a saddle, curved downward in one direction, curved upward in the other. A shape that never loops, a shape that never loops of but always opens wider the farther you go. That's the third possibility. P- These aren't just fun thought experiments, they're the three main shapes the entire universe might take. We call them flat, nesple, kemterien to become an edible let of the she, closed, good, and open. Let's explore each one softly, slowly, like tiptoeing across the fabric of reality. First, the flat universe. This one's easy to picture. It's like that endless sheet of paper, and no curves, no edges, no loops, no just space stretching in all directions. Can remember to fly our butt forever and ever. In a flat universe, two beams of light moving side by side would stay side by side. They'd never curve toward each other, Kim, and never drift apart. Walm's wall never did. This shape feels simple, calm, even familiar. And oddly enough, human corpions with beaked deft, die covered to Leo's celibacy, and were questionable that beverages belsuix oven cold, to bid naturfedi dutsend, and prepare for theory stuvior every bellapitauger, and prepare for you hope K. This might be the one we actually live in. According to the best measurements so far, our universe looks very flat. Not perfectly flat, but close enough because that if there's a curve, it's so gentle we haven't noticed yet. But let's keep drifting. Now imagine a closed universe. This is the balloon. Not because the universe is a ball, but because space itself is curved, like the surface of that balloon. If you traveled far enough in a straight line, you'd return to where you started. Well, just like walking in a circle, and without ever turning. This kind of universe is finite. It has a total volume, but it has no edge, but it has no wall, no place where it stops. It just loops. There's something strangely cozy about that. A universe that wraps around itself, like a blanket folded into a loop. For, and finally, the open universe. This one's shaped like a saddle, a gentle swooping curve that never closes back on itself. With in an open universe, space stretches outward in every direction, growing more and more apart as you move. It's infinite too, but in a different way. Open universes are the most dramatic. They expand quickly, they thin out over time, and they might end in a deep, eternal chill, with galaxies drifting apart until the stars go dark. Each of these three shapes, flat, closed, or open, tells a different story. Story Furial Pari, about where the universe came from and where it's heading. It also tells us something about gravity, energy, and the mysterious forces that shape the cosmos. So, how do we know which one we're in? With we look at the cosmic microwave background, the oldest light in the universe. By measuring tiny temperature differences in that light, we can detect tiny curves in space. And what do we see? Flatness, as far as our instruments can measure. But remember, that's only within the observable universe, the part we can see. What lies beyond that? We're not sure. The universe could be perfectly flat forever, or it could gently curve into something strange and unexpected, just past the edge of our vision. So tonight, as you rest and breathe softly, picture space like a silent piece of origami, folded into a shape too large to see all at once. Is it a sheet? A sphere? A saddle? We don't know for sure, but in the gentle hush of cosmic possibilities, each shape carries its own quiet beauty. And no matter what the universe is shaped like, you're part of it. You're curved or flat, looping or open. You belong to the shape of everything. And as the stars blink far above your roof, they're resting gently. They're on the folds of a fabric, avec way, wordy and buldy of tarot, weir heeds wads a wop, and steep that may go on forever, or fold back into itself like a dream. Either way, you are cradled within it, peacefully, to svodu, to endlessly. Well, imagine a smooth, endless sheet, like a perfectly stretched piece of paper. No folds, no bumps, no edges. It just keeps going. That's one way to picture a flat universe. Not flat like a pancake, but flat in the way space behaves. A universe where geometry works the way we're used to, where straight lines stay straight, where parallel lines never meet, no matter how far they travel. This idea of flatness comes from geometry. It's called Euclidean space, the kind of space you learn about in school. And a triangle's angles add up to 180 degrees. Circles have the same rules they do on paper. And if you shine two beams of light next to each other, they'll stay side by side forever. This is what scientists think our universe might actually be. As strange as it sounds, the universe doesn't appear to curve, at least not in any obvious way. But how do we know that? We can't float above the universe and look down at its shape. We're inside it, because you like fish in a bowl. In a velu tel way, could pretty upon can you or questionable bog, come tell what that way, will it their way, kings life in a raid bore, weed, in kimes the puther tathbrixa, trying to understand the shape of the water around us. So scientists look at light, specifically, the oldest light we can see, the cosmic microwave background. This ancient glow, left over from the Big Bang, carries tiny clues about the shape of space. And when we measure it carefully, precisely, we find something interesting. The universe looks very flat, not slightly curved, not looped or folded. If your betiv turned the rare poem with an repeaty, and hiding their bopal, or your bather bopal sufto, and for nar the rare, your way with the ball, just flat. This flatness tells us a lot. It means space isn't folding back on itself, like the surface of a sphere, and it isn't curving outward like a saddle. In a flat universe, you could travel in a straight line forever and never return to where you started. You'd never hit a wall. You'd never reach the end. You'd just keep going. That that also means the universe could be infinite, not just big infinite. No boundary, no outside, just more space and more and more. But a flat universe isn't just about shape, it's also about balance. There's a delicate tension between the pull of gravity and the push of expansion. If gravity were a little stronger, space would curve inward, like the skin of a balloon. If expansion were stronger, it would stretch space outward, don't like a saddle. But somehow they're matched almost perfectly, and so perfectly, in fact. We'll see that the universe appears flat. This raises deep questions. Was it a coincidence? Just luck? Or is there something else going on that we don't understand yet? Some scientists think flatness points to something bigger, Maybe our universe is just one part of a larger multiverse. Maybe the flatness is a clue that space goes on far beyond what we can see. Or maybe we're just in the middle of something that looks flat from our tiny view, like standing in a vast field that's and assuming the earth is flat beneath our feet. The truth is, we don't know for sure, but what we do know is that flatness works. It explains what we see, it fits the data, and it shapes how light moves, how galaxies grow, and how the universe will continue expanding. If the universe is truly flat, it could expand forever. Galaxies might drift apart more and more and more, but space itself would never curve and or loop back. It would just stretch calmly, endlessly, and we'd be drifting across it on a smooth, silent road with no turns and no walls. That's the flat universe, pinched, and from what we can tell, and it's the one we live in. Now imagine something different. Not a flat sheet, mirror, but a sphere. Not a ball you hold in your hand, that you, but a shape so big you don't even realize it curves. Picture walking in one direction, step by step, for a very long time. No turns, no walls, just forward. And one day, quietly, gently, you find yourself back where you started. That's what scientists call a closed universe. It doesn't mean the universe is closed off or sealed. It means space itself is curved, not in 3 dimensions like a globe, but in four, in ways our minds can barely picture. Still, we can try. The t- Think of the surface of Earth, or do it looks flat when you're standing on it. Walk a few kilometers and it feels like a straight line. But go far enough and you'll circle the planet, end up back home. Now imagine that idea, but stretched into the fabric of space. In a closed universe, space curves inward, not in a tight circle, but softly, slowly, across all directions. It's a universe without edges, but it's not infinite either. Pure that it's finite, it's yet unbounded, just like the surface of a sphere. You can travel forever without hitting a wall, and but there's only so much space overall, only so much volume, only so many paths. This kind of universe bends light in strange ways. Beams of light that seem to go off in different directions might curve around and meet again. It's a cosmic loop, a gentle folding of space itself. And it has strange consequences. If you could look far enough, really far, you might see the back of your own head, not with a mirror, and not with a trick, but because light would wrap around space. Behavior plod huer med pectamites. Behavior plod huer plod huer plod huer plod huer plod huer plod if huer plod huer plod in verchalvong from an havtalke pax while you are corpoitin spaces and return to you from behind. That's not science fiction. It's geometry. It's in the purest sense, plagued with the bore of Bermanta reals, a lot multiple tour, aftstel. In a closed universe, gravity wins. It tugs gently but firmly on space, pulling it inward over billions of years. And if there's enough mass, enough stuff, the expansion of the universe might one day stop, then slow down, then reverse. Galaxies would drift closer. Stars would gather. Everything would fall inward into what some call the Big Crunch. a quiet undoing of the Big Bang, the expansion rewound. Now, this idea has faded in recent years. The universe appears to be expanding faster, not slower. Dark energy pushes outward. There may not be enough matter to curve space that much. Well, still, the closed universe remains a beautiful idea. Elegant, symmetrical, whole. It speaks to something deep in us, for Masuetis, a longing for return, for closure, for closure, for cycles. In Jutlon, biasen hinid o wineticeps, like seasons, like stories that end where they began. There's something comforting about a universe where everything eventually loops back, where forward eventually becomes behind, where every journey ends at home. Some ancient cultures imagined the heavens as great domes above us, and others thought the stars circled in perfect spheres. In a way, they were trying to describe something we're still exploring now. A closed universe isn't the most likely shape, and then but it's not impossible. And thinking about it and helps us ask better questions. It helps us imagine space not just as big, but as connected, is woven into itself, bending quietly beneath the weight of time. So next time you look up at the sky, try to picture it. All of space, no, wrapped around itself like a great bubble. No edge, no outside, just space bending softly, guiding stars and light along its endless curves. And maybe, somewhere out there, light that left you long ago is curling back toward you again, following the shape of a universe, following that always finds its way home. Now picture something different again. Not a flat sheet, not a sphere, but something warped, bent outward like a saddle or a Pringle chip. If you're feeling hungry, this is what scientists call an open universe. It's a shape that curves, but in the opposite direction of a closed universe. Ewer, instead of wrapping back on itself, in Seher, was headier and newer every spart for great and part. Space bends outward, stretching farther and farther and far as you go. In this kind of universe, you could travel in a straight line forever, and you'd never come back to where you started because there's no loop, no curve that folds back, just space, gently stretching apart, dear in all directions, without end. It's a universe with no boundaries, and no limits, and no limits, and no but it's not flat either. It has a shape, a gentle dip outward that never stops curving. This is hard to picture. Our brains aren't used to saddle-shaped worlds. And remember to plugs, and remember to kebble sparring today about wall. But mathematicians and physicists see it clearly in equations and models. In an open universe, the geometry is strange. Is strange. Parallel lines, ones that start next to each other, to slowly drift apart. Triangles don't behave like they do on paper. Their angles add up to less than 180 degrees. Circles have bigger circumferences than you'd expect. It's a different kind of space, a wild, open kind, and it changes how light moves through the universe. In this shape, light beams spread out faster. Galaxies drift away more quickly, and the universe itself expands forever, but with a sort of looseness, a freedom to stretch more and more as time goes on. This kind of shape suggests a cosmos where gravity never quite wins, where matter isn't dense enough, to pull everything back together. Instead, expansion keeps going, with and going and going, slowing, maybe, but never stopping. Be the galaxies we see now, to Murdoch, will drift farther away. Unmolten, their light will stretch, fainter and redder with time, until they fade beyond sight. Beyond, eventually, only the closest galaxies will remain visible. The rest will vanish into darkness, and where the not because they're gone, they but because they're too far, too fast, as they this is the lonely fate of an open universe. An endless quiet expansion. No big crunch, please, no return, just a soft growing space that becomes more empty with every passing moment. Some models suggest that in such a universe, the stars will all burn out, the gas clouds will vanish, new stars will stop forming, black holes will evaporate, and what's left? And what's left is cold, silent, still. This is sometimes called the Big Freeze. Not an explosion, big, not a collapse, pure, just a slow fading into emptiness. And it's not sad, just quiet, a gentle fading of light and heat, like a candle burning lower, but never going out completely. An open universe might sound scary, but it's also peaceful, vast, pure fan appealed subbats, pure fan appealed Baniola's dream, free. It doesn't trap light. If you were hungered and to plike tief and opgrowy tier, if you and just manchi piba, and fair beurus, if you were hungered and to vieweth, it doesn't fold in on itself. It, it offers room, infinite room, like for photons to stretch. Curds you don't cothe, Badel the filtered water, fram dady herself the taffen, be question for mure ledenkabai, for galaxies to move, for time to pass without end, be and maybe in some distant part, new stars are still being born, new galaxies spinning into life, parts of space we'll never reach, but that still exist, a vet somewhere. Even in this open shape, the universe is filled with mystery, yet questions without clear answers, possibilities beyond our view. We may live in a flat universe, or a curved one, or a space that shifts shape in ways we don't yet understand. But imagining these shapes helps us feel the size of the cosmos, and not just how big it is, but how differently it can behave. And a saddle, a loop, a sheet. New space isn't simple. It's subtle and strange, and softly stretching in every direction. We're part of it, drifting through, curving gently with its shape. And that's what makes it so beautiful. So, how do we measure the shape of something we can't touch? Something that stretches across billions of light years? Something that includes us to, and everything we've ever known? You can't step outside the universe to take a photo. There are no edges to lean against, no angles to compare. But we do have clues, with faint ones. Ones, whispers from the past, frozen in light, and not the most helpful clue of all is something called the cosmic microwave background. And scientists usually just call it the CMB. It's not a sound, it's not a breeze. Good, it's light, but very old, and very faint. And this light comes from a time long ago, about 13.8 billion years ago, just after the Big Bang. The universe was still a baby, hot, Waturi and Yangan teeth, dense, and packed with glowing plasma. Then, suddenly, it cooled just enough for light to move freely. That first light, the oldest light, has been traveling ever since. It's everywhere, and it's all around you, filling every inch of space like a soft afterglow. You can't see it with your eyes. Emily, it's too faint. It's too faint for animal dung, the cause of bat na lane, in des mediqua iri. They call the blaze the furjank winnie, they call the thick donald thing for animal tar, too stretched. But special telescopes can see it, and what they've found is remarkable. The CMB isn't smooth, it's speckled, like a painting done with tiny dots. Tiny temperature differences, just millionths of a degree apart. But those tiny patterns hold the key to space's shape, because light behaves differently, depending on what kind of space it's traveling through. If, if space is flat, light follows straight lines. Patterns appear just the right size. If space is closed, curved like a sphere, light paths bend inward. The same patterns look larger, as if they're magnified. And if space is open, curved like a saddle, and a Y, light spreads out more. Patterns seem smaller, as if they're shrinking. So by measuring the size of these little blotches in the cosmic microwave background, scientists can tell what kind of space we live in. And what did they find? They found balance, a beautiful balance. The data shows that space is almost perfectly flat. Here's only scorpions to fordele peaking by the sky of ray, not curved inward like a sphere, not bent outward like a saddle, but straight, level, like a cosmic sheet, stretched smooth. This doesn't mean space is simple, or that the universe has no surprises, but it does tell us something deep. It tells us that space is balanced on the edge between too much matter and not enough. Just enough gravity to slow things down, but not enough to pull them back in. But it's a cosmic tightrope and a universe right on the line between collapsing and expanding forever. And that's surprising because in the early universe, things were wild and dense, Gurchbian, chaotic, and yet somehow, and everything ended up just right. That puzzle has a name, the flatness problem. Why is the universe so flat when it could have curved wildly in either direction? One possible answer is something called inflation. Not balloon inflation, not money inflation, but a sudden, faster than light expansion that happened in the first blink of time, after the Big Bang, in less than a trillionth of a second. Space stretched unimaginably fast. This smoothed out the wrinkles, flattened the curves, like pulling a crumpled sheet tight, until it feels flat beneath your fingers. And, and what's left, we're left to make, is the universe we see today. Wide, stretched, and nearly flat. The CMB is our fossil evidence, a glowing memory of what space was like at the very beginning. And every time we study it, we learn more about the shape of everything. It's amazing, isn't it, that we can look at ancient light from a time before stars, before planets bought, pure, before even atoms fully formed, and atoms fully formed, and learn about the very shape of space itself. From specks of light, we see the geometry of the cosmos. And while we may not know if the universe is truly infinite, and or whether it loops back in on itself someday, we do know this from what we can measure. Space appears smooth, flat, and gently expanding, a soft, quiet backdrop, and for everything that's ever happened. And that in itself is a beautiful thing to know. Let's imagine something simple, s- something small, something you've held in your hands before. A balloon. Before you blow it up, the balloon is soft and wrinkled, folded in on itself. Not much to look at. But then you breathe into it, and gently, and the balloon begins to grow. Now, take a marker, draw a few dots on the surface of the balloon. Here round, one here, devil or vine min, one there, maybe five or six scattered around. Now inflate the balloon more. Watch what happens to the dots. They, they start to move apart. Not because the dots themselves are moving, not because they're crawling across the surface, but because the surface itself is stretching. This is one of the most helpful ways to think about our universe. The expanding balloon analogy. The surface of the balloon that is like the fabric of space, but the dots are like galaxies. And just like on the balloon, as space expands, galaxies appear to move away from one another. But here's the strange part. There's no center and no edge. And you might think the center of the universe, Unitek, is where the balloon was being blown up. But in this analogy, we're not thinking about the inside of the balloon, only the surface. The universe isn't expanding into something, it's expanding within itself. Everywhere you stand, you are at the center because space is growing equally in all directions. Er, From every galaxy's point of view, all the other galaxies seem to be moving away. It's not that we're in some special place, it's that space itself is getting bigger. And imagine being one of those dots, and you wouldn't feel like you're moving, but you'd notice all the other dots move, drifting farther and farther away. Now, zoom out. Forget the rubber balloon. Picture space itself doing the same thing. The galaxies aren't flying apart like shrapnel from an explosion. They're staying still, they more or less, while space stretches between them. And the more space there is between two galaxies, the faster that space stretches. This is why distant galaxies, Builtunga, Bagley Peating, dem door the Plaid Fav Perumble to the Warigus Quux Ehishing, by Trick to need to Pickets, Winds what hoke to need Bultbrock, List ors of Wife Huidig, Romano Palto, and where's the mouth that Ed Canterk, more can you fermented, where it non sugalex bait, when halted herond a baby relto, seem to move away faster than closer ones. It's not because they're speeding away like rockets. They- It's because the fabric between them is growing like a thread being pulled. Longer and longer and longer, pure fan of trait of Bitsard and Claydens of Hugh Dorn, and nor blade played until it thins and fades. There's no outer shell, no wall of the universe, no final galaxy at the edge. Just more balloon, more dots, more space, me, and every point on the balloon is just like every other. No special spot, blue no favored corner. This kind of expansion feels different from anything in daily life. We're used to objects moving through space, a car driving on a road, a plane flying through the sky. But in cosmic expansion, it's the road itself that stretches, the sky itself that widens. Nothing needs to move. Space does the moving for it. Even light gets pulled along for the ride. Its wavelengths stretch, and turning from blue to red as the balloon inflates around it. And this gentle expansion the fedigo, passa after we kuvmas pkov. Nolser, passa after we kuven, has been happening for over 13 billion years. The balloon keeps growing. Not because of a force pushing it, because but because of how the universe began. In the beginning, everything was closer together, hotter, denser. Then, for reasons we still don't fully understand, space began to stretch, and it never stopped. Every moment, more space unfolds between galaxies, and the balloon breathes silently, growing on a way, for Modi Lawit spore, who've conbly horrible, samzikritamb, thum questionable civil, fatires without come they. We can barely detect from here, but the light tells the story. The galaxies whisper the clues, and we, tiny dots ourselves, ride gently on the surface of this ever expanding world. So next time you hold a balloon, think of the cosmos. Think of the galaxies drawn across it, not flying away, but drifting softly, carried by the quiet growth Krokru, the Rothothicoas, of space itself. Let's try something curious. Imagine you're standing on a beach. The sky is soft, will fertain, hope of the wind is gentle, the horizon stretches out in every direction. Now, start walking. Keep going through forests, over mountains, across oceans. They walk for days, and walk for days of Nomen Courts Bathri, for months, for years if you must, eventually, without ever turning around, and you'd return to where you started. Not because you hit a wall, not because the earth ended, but because the earth is finite yet unbounded. It has a surface that's limited in area, but it doesn't have an edge, and you can travel endlessly without falling off. That idea, so simple on Earth, might also apply to the entire universe. It could be finite but unbounded. Let's unpack that. When we say finite, we usually think of something small, a room, a box, something with borders, with a beginning and an end. And when we hear infinite, we imagine something so big, it goes on forever. But a hallway without walls, a sky without stars end. But there's another possibility. A middle path, something strange and beautiful. A universe with no walls, no fences, and no outer shell, but also not infinite, not endlessly wide, just wrapped in such a way that you could keep going forever, and always stay inside, like walking around the globe, but on a cosmic scale. This is easier to imagine with fewer dimensions. Think of a 2D world, a flat land with length and width but no height. In this 2D world, a creature might believe they live on an infinite plane. But if their world is actually the surface of a giant sphere, that they could walk forever and never reach an edge. Now stretch that idea into 3D. What if our 3D universe be questionable that PD was the surface of a 4D shape, not something we can see, not something we can picture fully, but something that curves space, but in a way that loops back on itself. In this kind of universe, you could travel in one direction, and after a very, very long time, end up back where you started. It wouldn't be magic. It, it wouldn't be teleportation. It would be space folding around on itself. Just like on Earth, if you on Earth, just like on Earth, decos turn, der spellest point, you wouldn't see a wall in the distance. Just more stars, more galaxies. You'd never notice the loop because the scale is far too big to walk, too big to fly, and you're all uncovered there, sir, stuff too big, even for light to make the journey, to since the beginning of time. This is what physicists mean when they say finite but unbounded, a universe that holds only so much, but stretches gently back on itself, from like a curve that never ends. It's a hard thing to picture. Our minds aren't built to imagine curved dimension, or infinite loops in space. It, but nature doesn't need us to understand her. She just is. And sometimes she whispers hints in the way galaxies cluster, in the shape of the cosmic microwave background, in the balance of space and energy. Some models of the universe suggest this looping possibility. They don't place us at the center, they don't put a wall at the edge, and they place us inside a gentle loop where space folds in on itself without a seam. So, in a sense, asking, where does it end, might not be the right question. There may be no ending, and no beginning either, just a shape, but a strange, quiet shape that lets us move forever without falling off. If you set out in one direction, you wouldn't hit a cosmic brick wall. You wouldn't drift into nothing. You'd just keep going, forever chasing your own tail, and then across the stars, just like the dots on a balloon, just like a traveler on Earth, just like a thought that loops back to where it began. The universe might not need walls need to be complete. It might not need infinity to feel endless. It may be shaped just right. Say, not too big, but not too small. Just round enough, and of tanksria, and of Kate was fur spexreed, and of Kate was furred woo, to hold everything we know, everything we are, and everything we still wonder about. A finite world with no edge at all. Let's try a simple question. Where's the center of the universe? If you're like most people, you might imagine it as a place, a fixed spot, maybe far, far away, maybe where the Big Bang began, a glowing middle from which everything else exploded outward. It feels like there should be one. After all, when something explodes, doesn't it have a center? A firework bursts from a point, a ripple spreads from a stone, a balloon pops, and everything flies away from it from one single place. But space doesn't work that way. The universe didn't explode into space. The space itself began expanding. And when space expands, it doesn't need a center. Imagine a raisin loaf baking in the oven, not a slice, the whole dough. As it rises, the dough stretches, and the raisins inside, they move apart, not because they're crawling through the bread, but because the bread is getting bigger. Now picture yourself as one of the raisins. You'd see all the other raisins drifting away from you. Tonight, you might think, I must be in the center. But then Ask any other raisin, and they'd say the same thing. To every raisin, it looks like the universe is expanding away from them. Well, that's what's happening with galaxies. From our point of view, better available would sidable betid, better veg and would available a jaspen feed itself, and wide fair kate. Ewing solve bar holsters and sort of though. Every galaxy seems to be moving away. The farther they are, the faster they flee. But if you were standing on another galaxy, millions of light years from here, you'd see the same thing. Galaxies moving away. No special center, no cosmic bullseye, just a smooth, even expansion and desasporing into Reldolscher weld of bolstery, happening everywhere at once. It's easy to get confused because on Earth, we're used to directions: left, right, up, down, front, back, center. But the universe doesn't have a top or bottom, and it doesn't have a middle either, at least not one that stands out. This might feel uncomfortable at first. Bekade Burr is a Charkov tonight fireball. We want to feel anchored, to know where we are. But in cosmology, everywhere is equally here. Exia, there's no cosmic throne, no privileged position, no master control room hidden behind the stars. With just space, warrior fall, expanding, cold, silently, smoothly, in every direction. When the Big Bang happened, it didn't explode into empty space, and it created space, not from a single point in the sky, but from every point at once. Well, that includes where you're sitting now, where your room is, where the Earth orbits, even where your thoughts are floating as you listen. Everywhere we look, we're looking outward from our own dot in the rising dough, and so is every galaxy. This is why the universe looks the same in every direction, why the cosmic microwave background is almost perfectly uniform. There's no bright corner where it all began, no darker side where it's all heading. The universe is, as far as we can tell, better for one that you wanted from Maine, the you far as we can tell of the to hatred hit homogeneous, evenly filled, and isotropic, the same in all directions. It's like standing in a vast fog. No matter which way you turn, and it stretches out evenly around you. So when we ask, where's the center? The answer is everywhere and nowhere. There's no central galaxy, no glowing point, and no cosmic North Pole, just you and the stars, floating together, floating in a sea that keeps stretching, with no anchor beneath it. Beneath it, the more space we observe, and the more we realize, walls that our position isn't special. But that also means no position is worse. Willie, no one is at the edge and left behind, and we are all in the middle of it. Each galaxy, tonight tharmoir to calyx percompoting shirt, each cluster, they will, each planet and particle, and riding the same expansion, vigresum pebble, and vidats densely, just faft from Mimble, and Cardistablon. From the purdier is a meeting him felt from wherever they stand. So if you ever feel lost, if the universe seems too big, you too strange, too cold to understand, to full, remember this. You're not at the edge. You're not on the outside. You are right in the center of your own patch of sky, just like every galaxy that shines from far away. And in a universe with no center, everywhere you are is exactly where you belong. Let's imagine something strange. You're floating in space, will- looking out at the stars. All seems still, all seems silent, but something is happening, not to the stars, to, but to the space between them. It's growing, not because someone is adding more stars, not because galaxies are flying through space, but because space itself is stretching, and it's doing so everywhere at once. We've talked about how galaxies seem to move away from us, how the farther they are, the faster they go. This isn't just motion, it's expansion, and there's a limit to how much of that we can ever keep up with. That limit is called, pure fantasy here there's Tamord, warned, the event horizon. Now, that term might sound familiar. You've probably heard it used to describe black holes. And yes, black holes do have event horizons. They mark the point of no return. Cross it, and not even light, the bees dot for minute pot, can escape. But the universe itself has an event horizon too, not because it's sucking things in, but because it's stretching them away. Imagine trying to shout across a canyon. If the canyon gets wider, the faster than your voice can travel, into which your words will never reach the other side. That's what's happening. Well explored what's happening with the boarding happening to first spots. Get a bald. Don't question probable of wath with light in the far universe. There are galaxies so distant that and space is expanding so fast that the light they're sending out right now will never ever reach us. Not because it's too dim, not because it's blocked, but because the space in between is growing faster than the light can move. That's the cosmic event horizon. It's not a wall, it's not a shell, it's not made of anything at all. And Watsy, it's simply the distance beyond which signals can never catch up. And no matter how long we wait, no matter how good our telescopes get, the universe's expansion isn't slowing down. In fact, it's speeding up, driven by something mysterious, something we call dark energy. Because of that, because of that, more and more galaxies are crossing that horizon. One by one, they slip beyond reach. And we nioi pines I recovered in the Todzerl, and my the Lockdoor Todio, and first the Knights lay to needs of, and few hollow bowls with their sarid pure, and few dare every, pures with the teasing of guabdop benigns of place of you. And someday, the only galaxies we'll still see will be the ones closest to us now. Will everything else will be lost to time, if not destroyed, they not erased, just disconnected, still there, still shining, still filled with stars and planets and light, and but forever outside, but forever outside my caring, our ability to see, and we're in that's the quiet tragedy of the accelerating universe, a slow fading, a gentle letting go. Each galaxy drifting beyond the edge of communication. The horizon is always changing. Not a fixed distance, but a moving boundary, pushed farther by the stretching fabric of space. Right now, it's about 16 billion light years away. Anything beyond that can still be seen as it was long ago, because its light had time to reach us. Before expansion sped up, But any new light or from beyond that edge is lost, not because it's dim, but because it's too late. Imagine watching someone walk over a distant hill. You see them vanish behind the curve, and you know they're still there, just out of sight. That's how these galaxies feel. Gone from view, or, but not from existence, is what. This is why astronomers sometimes say we live in a shrinking universe, not because space is getting smaller, it's growing faster than ever. But the part we can see, to the part we can study and touch with light, is slowly being carved away. The deeper we look for, the more we're seeing ghosts. Galaxies whose light began billions of years ago, whose current signals will never find their way here. The event horizon isn't scary. It's not dangerous. Ba- but it's humbling. It reminds us that we're not connected to everything forever, that the cosmos is bigger than our reach. And yet, we still get to witness so much. Billions of galaxies, trillions of stars, each one a gift from the past, a message that made it in time. So tonight, as you imagine the stars, think of the ones that slipped away, not lost, just resting where the tourist and battery deep to know, beyond the horizon. So far, we've looked deep into space. We've talked about galaxies that drift away, about expansion that pulls things apart, and about event horizons where even light gives up the chase. And but now, let's take a quiet step back, not out toward the future, but back into the past. Tonight, we'll talk about something called the particle horizon. It sounds technical, but it's not so scary. It simply marks the farthest edge of what we can possibly see. And to understand it, and we need to think about how light works. You see, when you look at anything, you're really just catching its light. That star? You're seeing light it sent out years ago. That galaxy? Maybe billions of years ago. Light takes time to travel. Thing to which Tarav Bureld to, and the farther away something is, and the longer its light takes to reach us. Now imagine the very beginning, the moment the universe began, the Big Bang. The, there were no stars yet. They no galaxies, just a hot, dense fog of particles and light all mixed together. And for a long time, this early universe was too thick for light to travel. It was like trying to shine a flashlight through milk. The photons just bounced around, trapped. But then, about 380,000 years after the Big Bang, everything cooled down just enough for things to change. The universe became transparent, and the first light finally broke free by the and began its journey. That ancient light is still traveling now, still stretching across the cosmos, and we can still see it. We call it the cosmic microwave background. It's the oldest light in the universe, for the edge of the observable past, and the place from which that light came. That's our particle horizon. It's not a wall. It's not a surface. It's a distance. The limit of how far light could have traveled since the beginning of time to reach us right now. Today, that distance is around 46 billion light years, light in every direction. Which might sound strange, since the universe is only about 13.8 billion years old. But remember, space has been expanding the whole time. So that ancient light has been moving through a growing universe. Its journey has been stretched, its path pulled longer. That's why the particle horizon, en wars hinders voor de pols in kutvers, en wijzige velder, beconverse why the pew, vermikking meat, van bikuzakalor hybrid, botic spoltif subber, isn't in 13.8 billion light years away. It's much farther. It defines the edge of our visible bubble. Everything inside it, all the galaxies, stars, and whispers of radiation, are things whose light has had time to reach us. And everything outside, still hidden, for now, still on the way, or maybe forever out of reach. Not because it doesn't exist, but because its light, Facertain to bit plight, Facertain just hasn't gotten here yet. So when we look at the night sky, we're really looking back in time. Each flicker is a story from deeper and deeper in the past. The particle horizon is the farthest chapter we're able to read. It's the ultimate time capsule, and it gives our universe its visible size. It's not its full size, not its true size, and just the part they
that sent us light.
in time to see it. Imagine standing in a dark field with a tiny lantern. You can only see as far as the light has traveled. The darkness beyond, it's not empty. Popido came just unknown. That's how the particle horizon works. It's the limit of light, the edge of awareness. Now, as time moves on, light from farther places will have more time to reach us. And that means our particle horizon is always growing. Well, little by little became, firster hope became. The cosmos reveals more stars, more galaxies, because more ancient light that finally makes its way to Earth. I finally makes its way to Earth. It's a beautiful thought, isn't it? That while you sleep tonight, a few more photon from the deep past will quietly arrive, each one carrying a tiny clue about where we came from. So the next time you look up, I know this. The night sky isn't just wide, it's deep. Is and the edge you see? That soft glowing sphere that would wrapped around our universe? That's the particle horizon, a bubble made of light and time, slowly expanding, inviting us to wonder just a little more out here in the quiet dark. Down. We've talked about many edges, edges of sight, e- edges of distance, edges of time. But tonight, Beacon let's visit a very special edge, one that isn't made of light, or even of space. It's made of math, of motion, of limits we can't pass, no matter what we do. It's called the cosmological horizon. Imagine this, you're floating in the middle of the universe. There's no up, no down, just stars and galaxies scattered in every direction. And way out there, some of those galaxies are moving away from you, faster than the speed of light. Wait, faster than light? Isn't that impossible? Well, yes and no. Nothing can move through space faster than light. But space itself, it can do what it wants. And we're canned luben you, who own tonight, and human crueled what tonight might you. And right now, Puin's expanding with everywhere. All the time. Not because of a big explosion, not because things are flying apart like debris, but because the fabric of the universe is stretching, and the farther away something is, the more that stretch adds up. so far away that that stretch becomes stronger than even the speed of light. And galaxies, they aren't zooming past us. How they're just riding the swell of space itself. And that swell is pulling them beyond reach. They're in that's the cosmological horizon. It's the line between what could ever influence us and what never will. No matter how long we wait, no matter how powerful our technology becomes, even if we sent a spaceship traveling at the speed of light, the, it could never catch up because the space between is growing too fast, like trying to swim to a shore that keeps drifting farther and farther away, faster than you can paddle. The cosmological horizon, is not a wall made of rock or stars. The Europophyllite that loved the ray for side poffel braiding to reprigijono rowel. The Yori, it's not even a thing, really. It's a limit, a shifting boundary, the 5B created by the equations that describe our universe. It separates the now from the forever unreachable. And it's not the same for everyone. Just like your horizon at sea, first depends on where you're standing. The cosmological horizon depends on where you are in space and time. For us, right now, it's about 16 billion light years away. That's the point where expansion wins, where light from beyond few can never catch up, no matter what. Even though the universe is about 13.8 billion years old, and for point 0.8, the horizon is farther because the space in between has been stretching all along. So this horizon isn't about age, it's about motion, and about limits on cause and effect. And if a star exploded beyond the horizon today, its light would never reach us. Not in a billion years. Not ever. It's not because of dust or distance. It's because of the rules. The math of the universe says that's too far. The horizon draws a gentle line between can know and will never know. But here's the twist. You- It's not fixed. As the universe expands, this horizon moves too. In fact, it's growing all the time. Slowly, silently, like a tide. The revealing more of the shoreline will never touch. Some scientists describe this as a cosmic loneliness, a soft truth that, as time moves on, Busaik but Isis more of the universe slips away. Not because it disappears, but because we simply can't catch up. And yet, there's something comforting about that too. But because inside our own horizon, they, we still have billions of galaxies from the trillions of stars, and more beauty than we could ever fully explore. And, and every night, the light from those places. Anistic Impalvins also aid about Walk 8 still pours in. Soft waves of ancient stories, but whispers from a universe that wants to be seen. Earth 1 is so the cosmological horizon, for all its quiet distance, Geminal 4 the passri heviu, sonundetected with kalquite bokorik sonte plots, for perigloid sonte plots of sunt, for Peterwood sold port the talk for becast beaten wheat thesicalopi, is also a kind of gift. It reminds us how precious the visible world is. It tells us that time and space are not just lines on a map, they're part of a living, breathing cosmos, a place where light dances, where distances stretch, and where even math draws soft boundaries and that stir our curiosity. So next time you look up, know that Beyond the stars, you see, there's more, so much more, not lost, not broken, just outpacing time itself. Tonight, we've traveled far, far. We've talked about light and time, about distant galaxies and shifting horizons, and about how the universe expands and how some parts of it are already lost to us forever. But what if? But what if? And this is a big what if. What if we, our entire universe in, is just one small piece of something even bigger? What if there are other universes out there? Not distant galaxies, not hidden corners of space, but completely separate worlds, each floating on its own, in a sea we can never touch. This is the idea of the multiverse, and it sounds like science fiction. And maybe it is, but some of the best scientific questions ever start out sounding that way. Here's the thought: our universe might be just one bubble, governed in a much larger foam, each bubble a universe of its own, and each with its own version of space and time, its own rules, its own physics. In our universe, light travels at a certain speed, atoms form in certain ways, stars shine, planets spin, could, and life like us can exist. But in another bubble, the rules might be completely different. Maybe gravity is stronger there. Maybe stars live only a moment, or never form at all. Maybe there are no atoms to work. Maybe time runs backward. Or maybe, Piersef to woe. Zarbwiji the tech cure, Iwertu wake are keyed, Telatarians, Throblu spitic sex. Just maybe, there's another version of you, wondering the same thing while lying in bed, or can slomsh uncall, and a paradig well steenhut on a world that feels oddly familiar. It's wild to think about, and there's no proof. Not yet. But science sometimes follows the math, and certain equations press, especially in quantum mechanics, well it's borthen joy your prive. Halico beacon pochitaked, with codes crocked, and cosmic inflation theory suggest that the multiverse might be real. Imagine blowing a bubble in gum, then another, and another. Each bubble grows and stretches, and never quite touching, floating in space. But that's one way to imagine how these other universes could form. During the early moments of our universe, space expanded incredibly fast. Some theories say that while our universe was inflating, other bubbles were forming too, each starting their own story, each going their own way. But here's the catch, and we can never visit them. Not because we don't want to, but because they exist outside of our space and time. They are fundamentally unreachable. No spaceship, no telescope, no beam of light can cross that boundary. It's like being in one snow globe, trying to shake hands with someone in another. The glass between is permanent. So, why do scientists even talk about this? Because the multiverse might help explain things we can't make sense of, like why our universe has just the right conditions for life, why the laws of physics seem so perfectly tuned. 'Cause if there are infinite universes, each with random rules, then eventually one of them was bound to get it just right. That, and that one, is the one we live in. UBOs, it's not proof, but it's one possible answer. Still, B. Feld Brard Hewert Tate. Contain Bicol T Well, you is hava piawat. There's something haunting about it, isn't there? Wel the dolma doctor obhalti, but it weed the recepting the stumeets, but it weed men court, bet un test incepting hoopchins. Brand to be Kerwin. The idea that beyond all we can see, beyond even the most distant stars, there might be other realities bubbling quietly, each with its own dreams, its own silence, its own endless sky. And we may never reach them, we may never know them, but still, we can wonder, and maybe that's enough, because wonder doesn't need proof. It just needs room to breathe. And the multiverse, true or not, gives our imagination an endless sky to play in. So as you drift off tonight, let your thoughts float, not just through this universe, but into the possibility of others. Soft, invisible, unreachable worlds that might be just as full of stars, just as full of questions, just as full of dreamers, fuel of dreamers, looking up. Here we are, floating in a quiet corner of the cosmos, looking up again, and asking another timeless question. And is space infinite, or does it end somewhere?
Does it go on forever?
Or will we someday circle back to where we started? It's a simple question, but the answer? But the answer, just spot of tomato tefener, like so many things in the universe, is beautifully complicated. Let's begin with the word itself, infinity. It sounds like a number, like something you could count to if you just had enough time. But it's not. It's not a number at all. It's an idea, a direction, a concept that means it never ends. You could count forever. Keep going past every galaxy, every cluster, dive to every wall of light, and never run out of space. That's what infinite means. Ferums awak sever. But is the universe really infinite? We don't know. Not for sure. It might be, but it also might be finite. Just very, very big. Here's something strange. A space can be finite, but still have no edge. Think of the surface of a balloon. It's limited. You could measure how big it is, but it doesn't have a border. No walls. Pureth tef, and Tatalav path their plive. Peck for pas of Bonthother Anaber Teltil, and fate for Halmi, Bonthother Borg for Pimper, and Wondav Kim Pef, Pack for Pim Pef, and Nebai Tover that dive. Peyton Moan bis in played falls. Nita mind came paf, pack to coo, for Epkinin et, carry a sectu sewer, for leads little mung, how fout wis. No end. If you keep walking forward, you'll eventually come right back to where you started. It's called being finite, but unbounded. Our three-dimensional universe could work like that too. It might wrap around itself in, in ways our minds can't quite picture. You'd fly your spaceship in a straight line for billions of years, only to end up back at home and from the other side. It's strange. It's but possible. And then there's the other idea that space truly is infinite, that no matter how far you go, there's always more. More galaxies, more stars, more space. In this version, the universe is like a never ending ocean. You could float forever and never find a shore. Which idea is correct? We don't know, but we've tried to measure by studying the way galaxies move, the way light stretches, The way ancient microwaves hum through the sky, scientists have looked for clues about the shape and size of space. And so far, everything points to this. And it might be flat. A flat universe has no curves, and so no loops. And in most models, being flat means infinite. But here's the thing, infinity is hard to prove because we can only see so far, only measure so much. The observable universe is huge, roughly 93 billion light years across. But that's just the part we can see. Beyond that, no telescope can look, no signal can reach us. So the question stays open, teasing us, stretching our minds. Some people don't like the idea of infinity. It feels too big, too messy, but others find it comforting. Because if space truly is infinite, then every possibility exists. Every arrangement of stars, every kind of world, maybe even every version of you. And not here, not close, but somewhere defecate near, and vase first in covers or crawled pop in the endless sea. Hope, of course, that's just a dream, a playful thought. We may never know what's beyond the cosmic horizon. We may never know what if the universe ends or just keeps going, but maybe that's okay because wonder isn't always about answers. Sometimes it's about standing at the edge of what we know, what and listening to the silence beyond, a silence that stretches forever or loops quietly back on itself. Either way, it's full of beauty. So tonight, as you lie back and close your eyes and imagine space stretching in all directions and how not rushing, not noisy, for me, just quietly existing. Maybe it ends, and so maybe it doesn't, with but it holds us either way, in its arms of mystery, in its language of stars, and wherever it goes, you're a part of it, always. Let's return to the big question, the one that's floated with us through galaxies, across cosmic horizons, and past the boundaries of what we can see. Does space ever end? By now, you've seen how complicated that question really is. We've explored edges that aren't edges, horizons made of math, and universes that bend and loop in strange ways. But here's a different way to think about it. Will uncovered route things of vast pan, but it was your seed, and covered kengled, but your housing for, well head in these peepee, dude, thwart your rating. Maybe space doesn't need an edge, not because it goes on forever, not because it loops like a balloon, but because the universe, like a thought, that, or a dream, or a feeling, and was never meant to be contained. Maybe space keeps going because wonder keeps going. Maybe we can't find the edge of the universe because we can't find the edge of curiosity either. Think of it this way, Tite, every time we look deeper into the sky, we find something new, a fainter galaxy, a more distant quasar, a strange flicker of light that doesn't fit our models. And every time we make a new discovery, our questions get bigger, not smaller. We don't solve the mystery, we stretch it. That's the nature of space, and maybe the nature of us too. From the very beginning, the universe has been in motion, expanding, changing, becoming. Even now, billions of years later, it hasn't stopped. It's still growing, still unfolding. Space is not just the stage on which things happen, It's a character in the story. It moves. It grows. It hums quietly with energy. And if space itself is always becoming, French, then maybe the question isn't where does it stop, but rather why would it need to? We want borders because we're used to them. Our homes have walls. Our cities have limits. Our maps have edges. But the universe didn't read our maps. It doesn't need to fit inside our lines. Maybe it's not that we haven't found the end. Maybe there was never one to begin with. A galaxy doesn't ask, where does the universe stop? It just spins, and burns, and burns, and drifts. Maybe that's what we're meant to do, too. We'll not find the end, and but float in the middle of it all in quiet wonder. Because wonder has no walls. It grows in every direction. It grows in you. Every time you pause to think about stars. Every time you whisper, what if? And that's what makes space so beautiful. Not just its size, not just its strangeness, but its invitation. It calls us to keep looking, to stay curious, to open our minds just a little wider. Even if we never get all the answers, even if the end of space is a mystery that no telescope will ever solve, that's okay, because maybe the universe keeps expanding, the lo- not to run from us, but to leave room for every question we haven't asked yet. So tonight, as you lie still and the world around you softens, let yourself imagine a universe with no walls, no stopping point, no final chapter, just more, you- and more, and more. Not because we need it to be infinite, and but because we need it to be open, like the sea, like a song, like a dream you never quite finish. Maybe space doesn't end because wonder doesn't want it to. And maybe that's enough. So now we've drifted together through the edges of space, only to find there might not be any. We've peeked beyond the stars, over horizons made of time and math, into shapes that loop, bend, or stretch forever. And with every step, the universe whispered not certainty, but invitation to keep wondering, to keep dreaming, to stay curious, even in the quiet moments before sleep. Because space, like you, is always becoming. It's not just what is, it's what could be. It holds galaxies and ghosts hope you enjoy age Steve Blade, what a dade do the log from Stret, and where can a whelm, light older than Earth, and questions we haven't learned to ask yet. It's not a place with walls, it's a thought that never stops unfolding. That. So tonight, we'll uncover check for breakfast. Rest easy in the knowing that you are part of that thought, part of this wild, beautiful, infinite story. And while the universe keeps expanding, you don't have to chase it. Home, you can just float, let go, breathe, because space doesn't ask you to solve it, only to feel it. A quiet ocean, filled with stars and silence, and maybe, somewhere far away, another dreamer, drifting too. If this sleepy voyage made your night a little softer, please tap the like button, subscribe to the Snoozy Scientist, and tell us in the comments where you're listening from. It's always a joy to see this little galaxy of dreamers spread across the world. Now, close your eyes. You've already traveled light years tonight. No, all without leaving your bed. And that, dear explorer, is the real magic of wonder. Sweet dreams, and I'll see you in the next night sky.